Good evening, students. Today we are going to discuss about the another topic called as a addressing modes. So till now we have seen the internal architecture of the 8086 microprocessor and also how exactly the stack memory is going to be accessed by the 8086 microprocessor. We have seen all those concepts. So in the present class we are going to study about the addressing modes. We are going to study about the addressing modes. Let us see what exactly the addressing mode. What is the meaning of addressing mode? Okay. Now. So addressing mode is nothing but the number of ways which are used for representing the location of the data are called as an addressing modes. So the number of ways that are used to represent the location of a data are called as addressing modes. For example, if you are taking your generalized example, that is a daily life example. So you may be called by your parents with some pet name, and you may be called by your friends with some other name, and officially you are having the separate name, means on records. So on records you are having the separate names. Okay, so means only one person is there. That person is going to be identified with different names. So it is just like that. Here also, in order to access a particular data available in so and so location, how many number of ways are there? How many number of ways are there that are going to be used by the 8086 microprocessor are called as addressing modes. Are called as addressing modes. Okay. So now in this class, we are going to study about the addressing modes which are going to be supported by the 8086 microprocessor. The addressing modes which are going to be supported by the 8086 microprocessor. So as we defined, the definition is nothing but the number of ways that are used for representing the location of the data are called as addressing modes. Are called as addressing modes. So, in order to explain the addressing modes in 8086 microprocessor, not only the 8086 anywhere, but to explain the addressing modes, to explain the addressing modes, to explain the addressing modes, what I'm going to do means I'm going to use one instruction as an example. I'm going to use one instruction as an example. Okay, now. So I'm using the one instruction that is nothing but move instruction. Move instruction, which is called as a data transfer instruction. Move instruction, which is called as a data transfer instruction. Okay, now. So let us see what is the operation of the move instruction. Okay, now before going to having the in detail explanation about the what is that addressing modes which are supported by the 8086 microprocessor. Let us see one definition that is the functionality of the move instruction, because we are supposed to know what exactly the move instruction is doing. After that, we are going to make use of the instruction to explain the different types of addressing modes. Okay, so here we are having the move instruction. So move instruction is a data transfer instruction. Move instruction is called as data transfer instruction. Okay, now it is a data transfer instruction. So what is the use of the move instruction means? It copies the source content into the destination without changing the source content. Means it looks like this. Okay, now it copies the source content. Move instruction copies the source into the destination. Instruction, move instruction copies. I'm just taking the D for destination and source, S for source, which means copies are in simple format destination in simple format. So how exactly it is working means in simple way. I'm just writing the comment. Uh, Destination is equals to the source. Destination is equals to the source. Okay. Now. So move instruction which copies the source content into the destination. Which copies the source content into the destination without changing the source content. So that is what the move instruction. Okay. Now. So move is a data transfer instruction which is used for copying the source content into the destination without altering the source content. Without altering the source content. That is what the definition we are having right over here. Now, using this instruction, we are going to see the explanation of different types of addressing modes which are going to be supported by the 8086 microprocessor. Again, addressing modes are nothing but the number of ways that are used for representing the location of a data are called as an addressing mode. It is just like having a person with a means a person is going to be called by called with different names by different peoples. Okay, now. So means friends are going to have some nickname, parents are going to have some pet name, and Wait a minute. Parents are having some pet names at home, and actual name is different. Okay, now it is just like that only. So here let us go for the what are the different types of addressing modes which are going to be supported by the 8086 microprocessor. Okay, now so here based on the different ways which are used for representing the location of the data, the addressing modes broadly means the addressing modes which are going to be supported by the 8086 microprocessor are immediate addressing mode, immediate addressing mode, register addressing mode, memory addressing modes, and the memory addressing mode further divided into further classified into five types. One is the direct addressing mode, next one is the register indirect addressing mode, based addressing mode, indexed addressing mode, based indexed addressing mode, and the last one is a port addressing mode. So what exactly the port addressing mode means, which is going to be this addressing mode is going to be helpful in exchanging the data between the microprocessor and the input output ports to which we are connecting the input output devices. Okay, now we'll see one by one, no problem at all. So let us define what exactly the immediate addressing mode. So if you see the definition, the immediate addressing mode says that we have taken the move instruction now. So in move instruction, we are having the source as well as the destination. Move means the syntax is move space destination comma source. So here in this addressing mode, source is always the constant, some numerical constant, some numerical constant. That may be the 8-bit number or that may be the 16-bit number. That may be the 8-bit number or that may be the 16-bit number. Okay now. So here, for example, in this addressing mode, as I said, in this addressing mode, source is a constant and the destination may be any register or the memory location. Whatever the destination we are having, that can be represented in 24 different ways in 8086 microprocessor. What exactly those 24 different ways we'll see in the upcoming classes, don't worry about it. So here the source is always the constant, that may be the 8-bit data or the 16-bit data. Okay, so here if you see this example, in this example what I'm doing is I'm taking the move instruction with the AL as a destination and 24H is a constant value. Means 24H is the value, constant value, 8-bit constant value, which is copied into the AL, which is a 8-bit register. AL is nothing but the accumulator lower byte, which is also the 8-bit register. Remember, ma, in any addressing mode, in the immediate addressing mode, in the immediate addressing mode means from one addressing mode to another addressing mode, the concept is going to be changes. Okay, so in the immediate addressing mode, both operands are nothing but the registers, that means the destination or the source registers. Both operands should be of same size. In immediate addressing mode, both operands should be of same size, means whatever the data you are trying to copy, if it is a 8-bit data, then the destination register should be the 8-bit register only. Destination register should be the 8-bit register only. If you are taking the memory location, then it is going to take only one memory location to copy to store the 8-bit data, because we have seen that from the 8085 onwards, in the last class we have seen one statement called as from 8085 memory 8085 microprocessor onwards, whatever the memories which we are having to interface to the microprocessor, each memory location of that particular memory is able to hold the 8-bit data. If you want to hold the 16-bit data, obviously you are supposed to use the two memory locations. Okay, now so that is what the concept. Okay, so here whatever the source were content, so here the source is nothing but the a constant value, destination is nothing but the some accumulator lower byte or any 8-bit register. So both operands are of same size. Okay, now so in the second example I took 16-bit register accumulator in the 16-bit format. So obviously I'm having the 16-bit number because I'm having the 4-digit hexadecimal number now. So each digit is in order to represent each digit we require the 4 bits, as we know, we have seen in the last class. So total 1 2 3 4 means they are the 4 digits, 4 hexadecimal digits. So obviously it is a 16-bit number. So this particular 16-bit number is copied into the 16-bit register which is a AX. 16-bit register which is a AX. If both operands are not the same size, then it is highly impossible to perform the immediate addressing mode. What I mean to say that if you are having the, for example, if you are using move instruction, if you are using move instruction, move al comma al comma uh, 1 2 3 4 h, then this kind of operation is not acceptable. This kind of operation is not acceptable. Okay now. It is not acceptable. It is just because this one is a 16-bit data. 1234H is a 16-bit data, but the destination is a 8-bit. So it is highly impossible to copy the 16-bit data into the 8-bit number. And one more way also. One more way. So if you are having the move instruction, move with the what we say AX comma 1 to H. So it is also not possible because both operands are not in the same size. So destination is a 16-bit register, source is a 8-bit number. So copying the 8-bit number into the 16-bit register is not possible, okay, now, which is not acceptable. So this instruction is also not acceptable by the 8086 microprocessor. And one more thing is we are having the segment registers now. We are having the segment registers. If you want to copy some content into one of the segment register, that should be done via the accumulator. What I mean to say that, let me take one simple example. Assume that I would like to copy the some data into the data segment register. So I'm assuming that data is nothing but 3456H. I would like to copy the 3456H 16-bit data into the 16-bit segment register, which is nothing but the data segment register. So this operation is also not possible. This operation is also not possible. Why it is not possible means you can't write, you can't perform the, or in simple way, you can't perform the immediate addressing mode on the segment registers. You can't perform the immediate addressing mode on the segment register. Let us suppose there is a there is a situation in such a way that you are supposed to copy the 345H into the DS register. At that time, what you are supposed to do means first copy this data into the accumulator, 16-bit accumulator, and from there to the DS. What I mean to say that, so we can replace this one like this: move space AX comma 3456H. I'm just taking your textbook examples because you are going through in the textbook, right? So I'm not going to confuse you people by taking the different explanation. Okay, now 3456H. Now I'm going to copy the same content into the DS register. Okay, now. So I'm going to copy the same content into the DX register. So this one is a example. So the down one is the example for the register addressing mode. But forget about that one. We'll define the register addressing mode also. But when you would like to copy some content, some immediate value, which is a constant value, that is a 16-bit number into the segment register, any kind of segment register, it is not possible. So if you want to copy anything into the segment register, that should be done via the accumulator. That should be done via the accumulator. From the accumulator means copy the 16-bit number into the accumulator, from the accumulator into the corresponding segment register. That may be the AS, that may be the DS, that may be the SS, that may be the ES. But it should not be the what we say CS. CS is not going to be the destination at any case. Okay, now CS is not going to be the destination. Code segment is not going to be the destination. Okay, so this is all about our immediate addressing mode and what is the rule and regulations in immediate addressing mode. If you are having any doubts regarding this, you can raise. And the next type of addressing mode is nothing but next type of addressing mode, which is nothing but the register addressing mode. So in this register addressing mode, both operands are the registers. In this register addressing mode, both operands are the registers. Okay, both operands are registers. Look at this one. This one is also one register. This one is also one register. But whatever the operands, whatever the registers we are having in the in this example, those of same size now. Means same size means AL is a 8-bit number, BL is a 8-bit number. Don't think that AL BL only is going to be copied. If you want, you can take this one also. Move AL comma BH also. Okay, now move AL comma BH. Better to take the caps to show the instructions because there is a rules. There are certain rules when writing the program. We'll come across that one. It has to move on. So move AL comma BH. BH means here whatever the registers which are participating in the addressing mode, those should be of same size. So here in the AL is a 8-bit register, BH is also the 8-bit register. So register addressing mode is nothing but the destination and the source both should be the registers only. Both operands should be registers. Both operands should be registers, and both operands should be of same size. For example, I'm going to take one example. Okay, I'm going to take one example like move AL comma BX. It is not possible because BX is a 16-bit number, AL is a 8-bit number. And one more thing is a move AX or DX comma AL. this one is also not acceptable. Okay, now this one also not acceptable. This one is a not acceptable one, and this one is also the not acceptable one. But which one is going to be acceptable? Why these two are not acceptable? Because both the operands are not in the same size. But one this one is going to be acceptable one. If you see this explanation, this example, the second example what we are having, in this case both operands are of 16-bit registers, so you can copy the 16-bit content of one register into the another register. Okay, now so this one is going to be the acceptable one. So in short, what is that? In short, register addressing mode is nothing but whatever the operands which are participating in the instructions, those both operands should be the registers only, and both should be of same size. Both should be of same size. Okay, now. And let me tell you one more point that so here this kind of operation is not possible. Means copying the source content into copying the registers means you are having the segment registers, like a DS. Yeah, you are having the segment registers like DS, uh, SS, ES, CS. Okay. Now. So here you can say that these are the 8-bit, 16-bit registers as we know. They are the segment registers. But copying one of the segment register into another segment register is also not acceptable one. Which what I mean to say that control T. What I mean to say that if I am writing a move ES comma DS, it is not acceptable one. It is not acceptable one. Means segment register to one segment register content to copying into the another segment register content is not possible. It is not going to be possible. Okay. Now. So this is not the acceptable instruction. And one more thing is, if you want to copy anything, if you want to copy the DS content into the ES, that should be done via the accumulator. What I mean to say that first I am going to copy the what is that, a DS value into the AX, and after that I am going to copy the AX value into the ES. Okay, this one is going to be acceptable one because segment to the register to another segment register copying is not possible. Okay, it is not possible. And one more thing is, the destination SEMA CS register should not be the destination. Means if I'm writing the CS comma AX, you think that we are copying the AX content into the code segment register. So over here it is okay, but here it is not possible. Means CS register should not be the destination. CS register should not be the destination. Code segment register should not be the destination. Okay, no? So that is what the rule in register addressing mode. Not only in the register addressing mode, everywhere means in simple case, when you are trying to use the CS as a destination register, then that one is not going to be acceptable one. Okay, no? So these are the what we have, so whatever the explanation we have seen, they are the rules and regulations in the register addressing mode. Okay, now so register addressing mode is nothing but both operands should be the registers, and both should be of same size, and both registers should not be the segment registers. So if you want to exchange one of the segment data with another segment, one of the segment register content into another segment, then that should be done via the accumulator. That should be done via the accumulator. Okay, now so here in this addressing mode both registers should be of same size. So the next case is a memory addressing mode. So what exactly the memory addressing mode is a question. So memory addressing mode is nothing but when we are taking the one instruction, obviously we are going to have the source as well as the destination. So in this addressing mode, memory addressing mode is nothing but in any instruction, either the source or the destination, is going to be the memory location. It is going to be the memory location, and both should not be the memory locations. Means when you are taking one instruction, that is a move instruction. For example, I am taking the move instruction, control T, move instruction. So if I am taking the move here, either the destination, say syntax is D comma S, means the destination comma source. In this case, either the destination or source, any one of these two operand may be the memory location, but both of these operands should not be the memory location. Both are not going to be the memory, but one of the operand may be the memory location. So that kind of addressing mode is called as a memory addressing mode. Means in memory addressing mode is nothing but in a particular instruction, either the source or the destination, is going to be the memory location, and other one is maybe the data or the register, whatever the ways we are having. Using that ways, you can represent the other operand. Okay, now, if at all one operand is a memory location, other operand may be represented as a represented using the either the register or using any one of 24 ways which are going to be supported by the 8086 microprocessor. Okay, so memory addressing mode. So depending on the way means how many types of accessing possibilities are there, and how many types of accessing possibilities which are going to be supported by the 8086 microprocessor. The memory addressing mode is further classified into 5 types. One is the direct addressing mode, next one is the registered indirect addressing mode, next one is the based addressing mode, next one is the indexed addressing mode, next one is the based indexed addressing mode, next one is the based indexed addressing mode. Okay, now so let us see what exactly the each and every addressing mode. What exactly the each and every addressing mode. Okay, now. So if you want, you can note down this definition what I gave in this addressing mode. Either the source or the destination operand representing the address of a memory location, uh, but both operands should not be the memory locations. Okay, now. So the supporting values means the different types which are supported by 8086 microprocessor as a memory addressing mode are the first one is going to be the direct addressing mode. Direct addressing mode means in this addressing mode means this addressing mode is going to use either the source as a source or the destination as a memory location, either the source or the destination as a memory location. If you see this one, I'm having the move instruction, and here previously we have seen one concept called as a immediate addressing mode. Now if you see this one, move x comma 1234h, look at ma, here I'm having one constant without any square bracket. Here also I'm having constant without any square bracket. Okay, so if I'm having some constant without any square bracket, then it is going to be the what we say, it is going to be uh, the value, it is going to be the constant data, it is going to be the data. If at all we are having something, we are having some numerical value within a square bracket like this, within a square bracket like this, then this, if whatever the 16-bit number you are having within the square bracket, this 16-bit number is representing the offset address of a segment, means offset address of a segment. So this particular 16-bit number, whatever the 1234h we are having, this offset, this one is representing the offset address. Okay, so if at all any 16-bit numerical value is written within the square brackets, then that particular numerical value is representing the offset address. Now the question comes that this offset address belongs to what? Means how many segments are there? We are having the 4 segments. Out of 4 segments, this offset address belongs to which segment is a question. So here we know one rule that when you want to write the what is that 20-bit physical address, we are having one rule. 20-bit physical address is nothing but you are supposed to write the base address colon offset address. Base address colon offset address. Okay. But if you see over here, we are having only the offset address. We are having only the offset address. We are not having the base address. If at all you are having one instruction like this, let me rewrite this instruction. Let me rewrite this instruction because it is overwritten. So if at all you are having any instruction like this, what we say, the move instruction space 1234h. Not only 1234h, any value you can take 1234h comma a. So if you are having this kind of 1234h like this, and here 20-bit physical address is nothing but we are supposed to have the base as well as the offset, but here we are having only the offset. This one is representing only the offset address. Now this offset address, if at all the base address is not specified as a part of the instruction, then the default segment register or this particular offset address is going to be used as a offset address in the data segment, or the default the default segment which is used by the microprocessor when you are not representing the full length 20-bit physical address. When you are not representing the full length 20-bit physical address and you are representing only the offset address, you are representing only the offset address. Okay, now you are representing only the offset address, then that by default, then by default this offset address belongs to the data segment. This offset address belongs to the data segment. So in this example, whatever the 1234h you are having now, so this 1234h is representing the offset address in the data segment. Means when the microprocessor is trying to execute this instruction, this in a short instruction means we are not representing the base address now. This instruction is going to be replaced while executing. This instruction is going to be replaced like this: ds colon square bracket 1 2 3 4 h square bracket close, comma ax, which means ax is the source value 16-bit number, and this 16-bit number is going to be stored in the data segment whose starting offset address is the 1234h, whose starting offset address is the 1234h. So 1234h is representing the one memory location, but how many memory locations we require to hold the ax register content? Because ax is a 16-bit now, we require the two memory locations. Because of that, what the microprocessor will do means, whenever you are having one address like this, don't get confused. We are going to elaborate this explanation. We are just trying to elaborating this explanation. If you see this one, here you are representing only the one offset address. Here you are representing only the one offset address, but we are whatever the x is having, it is a 16-bit number. One offset address is able to hold the 8-bit number. So but if you want to hold the 16-bit number, by default, without knowing to you, what the microprocessor will do means, the lower byte of the ax is going to be stored inside the specified offset address. The lower byte of the ax is stored inside the specified offset address, and the higher byte is going to be stored in the next higher memory location. What I mean to say that, so I'm going to write this one as ds sorry ds colon 1234h memory location is holding the, I'm just writing the equal symbol, holding the lower order byte of the accumulator. Lower order byte of the accumulator. Now the ds colon next higher order memory location is a 1 2 3 4 5, right? 1 2 3 4, sorry, 3 5, 1 2 3 4 is over, 3 5h. In this memory location, the microprocessor is storing the higher order byte of the accumulator. Microprocessor is storing the higher order byte of the accumulator. Okay, now remember that whatever the offset address we are specifying, this offset address is representing the lower order, means in this particular offset address, lower order register content is going to be stored, if at all it is a 16-bit number. Okay, now so it is a 16-bit number. Now lower byte is going to be stored in the 1234 memory 1234h memory location, and higher byte is going to be stored in the next memory location, which is a 1234 1235h 1235h. Okay, now so here we are not specifying this information to the microprocessor, but the microprocessor is automatically increments the offset address by 1 depending on your destination source size. Depending on your source size, for example, I'm having the one instruction like this. For example, I'm having the one instruction like this. What is that instruction? Move what is that? Star, sorry, square bracket. What I'll do is I'll take the yeah, this is intersect level. Okay, no problem. I'll take move. Okay, I'll take the move square bracket 1 2 3 4 h comma a. In this case, only one memory location is going to be used by the microprocessor, because AL is a 8-bit number. One memory location is more than enough. Because AL is a 8-bit number, one memory location is more than enough. Okay, now so means here, the when you are trying to execute this instruction, then the microprocessor is storing this value AL content into the 20-bit address specified like ds colon 1234h 1234h equals to a. 1234h equals to a. Okay, but here here it is a 16-bit here it is a 8-bit number now. So as it is an 8-bit number, only one memory location is going to be used, and whatever the memory location you are specifying as a part of the instruction, that is going to be used. But in this case, you are using the 16-bit number now. You are using the 16-bit number as the source is a 16-bit number, without giving without giving any extra information. What the microprocessor will do means, it is going to be make use of the two consecutive memory locations to hold the 8-bit number. Two consecutive memory locations to hold the 8-bit number. Again, let me rewind one more time that the lower byte is always stored in the lower memory location. Higher byte is always stored in the higher memory location. Remember that. So if you see this one, 1234h is a lower memory location. That's why it is holding the lower byte. 1235h is a higher memory location. That's why it is holding the higher memory location. And during the stack explanation, I told you that one. So because of that, the microprocessors are called as little endians. Because of that, the microprocessors are called as little endians. Okay, now. So 1234H and 1235H. So this is the default one. Means if you are not specifying, any uh, base address over here. Here we are not having the any base address. So means we are not having the 20-bit physical address format. When we are not having any 20-bit physical address format, whatever the offset address we are having over here, that offset address belongs to the data segment. That offset address belongs to the data segment. No, sir, I am not interested like that. I would like to make use of this offset address in the extra segment, not in the data segment. In the extra segment, not in the data segments. For that, what I am going to do means, what you are supposed to do means, whoever is going to write the program, you are supposed to explicitly mention the 20-bit address like this. You are supposed to explicitly mention the 20-bit physical address format. So here I am taking the base address coming from the segment extra segment register, and offset address is the 1234H. So in this case, this offset address belongs to what? This one is the means without representing this one. Here we are not representing the 20-bit full length 20-bit one. So default segment register is going to be the data segment. Default segment is going to be the data segment. But if you take the if you want to specify a particular segment, extra segment, I would like to store the data into the extra segment, then what you are supposed to do means, you are supposed to explicitly mention the address in the 20-bit physical format. In this case, this offset address, whatever the offset address we are having, this offset address belongs to extra segment. This offset address belongs to extra segment. So that's why we are having the we are specifying the, as we are specifying the explicit 20-bit physical address. Means by specifying the 20-bit physical address format, you can uh, specifically mention to the microprocessor that which segment area you are going to use to store the data. Which segment area you are going to use to store the data. One more confusing point is also there. So here, if you see this one, I for my explanation point of view, I took the 34H. If you see this one, it is a even offset address, even number. It is a even number. If you want, you can take the odd number also over here. If you want, you can take the odd number also. But for that, what will happen is, lower byte is going to be stored in the odd address, higher byte is going to be stored in the even address. That is going to be very conflict one. So I'll clarify that one during the explanation of the memory interfacing to the microprocessor. During the explanation of the memory interfacing to the microprocessor. But let me draw one important point for that. So let me draw it only once. I'll take the blue. Okay. What I was saying. Yeah. Okay. So here I'm just taking a move space ds. So, explicitly, if I mention, if you want, you can mention explicitly. So whatever the explanation I'm saying giving over here, this one is common for all the segments. Common for all the segments. ds colon uh, 1 2 3 5 h. I'm not taking the even number. I'm taking the odd number, comma ax. In this case, what will happen? ds colon 1235H, ds colon 1235H is holding the lower byte. Unfortunately, it is holding the lower byte, which is nothing but the A. But ds colon 1236H is holding the AX. Sorry, AH value. Okay, now don't get confused right over here. Actually, lower byte memory location should always be stored inside the even address, not in the odd address. It is not mandatory, but if you are taking the even offset address to hold the lower byte, then the execution speed is going to be increased. Because why the execution speed is going to be increases, so we'll see that one during the explanation of the memory interfacing to the microprocessor. Just remember that if the offset address is starting offset address, whatever the offset address you are mentioning in the instruction, whatever the offset address you are mentioning in the instruction, whatever the offset address you are mentioning in the instruction, if it is a odd number, odd address, if it is a odd address, if this one is the odd address, then the microprocessor is going to be takes the two bus cycles. Microprocessor is going to take the 2 bus cycles. If at all this one is the even address, means whatever the offset address you are specifying in the instruction itself. If it is the even one, then in one bus cycle the execution is going to be done. Why it is taking the 2 bus cycles, we will see that one later. But in general, if you are having the odd address in the instruction part, then obviously lower byte is going to be stored in the odd address, higher byte is going to be stored in the even address. At that time 2 bus cycles are going to be used. Why the 2 bus cycles are used, we'll see that one, don't worry about it. But what you do is try, if you want to speed up your execution, then better to use the even offset address. This offset address as a even number, not the odd number. If you are taking the odd number, 2 bus cycles are going to be used. But if you are taking the even number, only 1 bus cycle is going to be used by the microprocessor to execute that particular instruction. Because we are supposed to consider all these points also when you are writing the program and expecting the result from the microprocessor in the fast manner. Okay, so don't worry about it. We'll continue. We'll see that one as we move on. We'll see that one as we move on. Okay. So for I think for today's class, I'm going to end up over here in the direct addressing mode. So in the next class, we are going to see the remaining addressing modes. Uh, So till now, if you are having any doubts regarding the explanation of this addressing modes, what we have seen till now, uh, let me know in the WhatsApp group. Okay, now don't get confused. So as we move on, you can easily learn. But what you do is you are supposed to follow the classes regularly. Okay, now if you are not following the regular classes, then definitely you are going to get confused, because whatever the programming part which we are going to see in the upcoming classes, program is writing a particular program using the microprocessor is nothing but remembering the logic of that particular program. No need to by heart the program. I'm not going to let you people to by heart the program. You should practice and you should remember the logic and implement your own program. I'm not going to restrict you that you should write my program only in the exam and my program only in the practical externals. Okay, no, it is not like that. You can write your own program, but the final thing at the end of the session, whatever the program you are writing, it should get work out. Okay, no, it should give the appropriate result what we are expecting. If it is not giving the result, then obviously your program is wrong. Okay, no. You can write your own program, but the result should be the same. Okay, now, thank you. We'll continue in the next class with the remaining addressing nodes. Thank you for now.